Hi class, this is your video lecture for Tuesday, January 26th. We start off today with some bell work, and we're going to go over some of the stuff we learned yesterday about chemical bonds. The first problem here asks us to write out the full electron configuration, our full electron configuration. So if you remember from your periodic table, we're just going to read until we come to the element. We want to read until we come to nitrogen. So we read our first row in our table, periodic table. It's our first row. Our first row only has an S level, and there's only 2 atoms in that. Then we have to start reading on our second row. If you start in your second row, so we're going to start here with a 2. We can counter our S block all the way on the left of our periodic table. There's 2 electrons, 2 atoms in that S block. Continuing on in the second row, so we have another 2. Then we are on our P block. Nitrogen's our third element in. Okay. And we're going to do the same thing with the rest of them. We're going to read until we get to the element we're looking for, sodium, bromine, or argon. Then it asks us to put a box around our valence electrons. I'm going to do, let's see, we'll do a box here. So we want to put a box around our valence electrons. Remember, the first thing you got to do is you've got to find what is your highest energy level. And in this case, our highest energy level is energy level 2. Right? So we're going to put a box around everything that's in energy level 2, our 2s and our 2p. Right? Similar then, when we look at our sodium, what's our highest energy level? It is our 3. So we're going to put a box around our 3s1 here. Those are our valence electrons. We get to bromine, it gets a little tougher, but you just got to be careful. Right? We see that 4 is our highest energy level. We need 2 boxes to do this one, right? Because that 3D gets in the middle, gets in the way. We only want the 4th level, the highest energy level that our atom has. And then finally, argon down here, 3s2, 3p6. So then we got to figure out how many valence electrons are in each one of these. So we're going to take a look at what did we circle. And we saw here we circled the 2 and the 3. So this guy has 5 valence electrons. Nitrogen does. We're going to look at, which also matches its group number, remember. Nitrogen, there's only 1 electron inside there in the circle, so we got 1 electron. Bromine, again, count what we've put in our boxes. 2 from our 4s, another 5 from our 4p. There are 7 valence electrons here in our bromine. And then finally, argon, we got 2 from our s, 2 from our 3s, 6 more from our 3p. We have 8 valence electrons here. Are these elements stable? Why? Yes, there's one of them stable. Right? Remember, we talked about if it's stable, it's gonna have 8 valence electrons. That's what we want. An element wants to be stable. Well, argon meets that. Its third energy level is completely full, 3s2, 3p6. It's got 8 electrons, 8 valence electrons. None of the others have those 8 valence electrons. Let's look at the next part. Flip over our bell work, and we go to the next part. How many valence electrons are present in each of the neutral atoms? Remember, all we got to do here, guys, all we got to do here is we just use it matches the group number. Matches the group number. So you just look on your periodic table, write down what you saw for your group number. And we're going to see it's real easy, right? Borons in group 3, beryllium's in group 2, chlorine's in group 7, oxygen group 6, etc. Just write down the group number. We get to the octet rule. It's still not too hard. It just takes one more step. So let's be careful how we do that next step. To do this, it helps to have your periodic table in front of you. Right? And yesterday in class, we went through and we labeled the top of our periodic table. We had gone through and we added, right, how many valence electrons there were in each group. Right? We added those valence electrons. Remember, helium here, it's our exception, even though it's in group 8, it only has 2. And then on top of that, we went through and we said, well, what's a stable charge? And we put all these lists on here like this, right? Column 1, group 1, its stable charge is +1. Column 2 is +2, its stable charge is +2. Column 3, group 3, stable charge is +3. So what that tells you, group 1 needs to lose 1 electron to fall back to a full shell of 8. Group 2 needs to lose 2 electrons to fall back to a full shell of 8. Because they're losing electrons, they're losing negative particles, right? They're going to have a positive charge. Similar for group 3. We get to group 4, we've kind of hit our turning point, right? We could lose 4 electrons, or we could gain 4 electrons. Either way, we can get to our full outer shell of 8. That's why things in group 4 can either become a stable charge of +4 or -4. You get to group 5, now we're getting closer to the full shell on the right side here. It's easier to pick up 3 electrons than it is to lose the 5 that it has. So it's going to pick up 3 electrons, 3 negative particles. It's going to have that charge of -3, right? Group 6 it only needs 2 more to get to its group 8, and group 7 needs only to get 1 more. And of course, then group 8, it's already got 8 electrons. It doesn't need any more. So let's go through and look at our bell work and how that plays out in our bell work. Use the octet rule to predict the ionic charge for each of the following. So we're going to go find argon in our periodic table. Right, argon. Here's argon sitting here. It's in group 8. So its stable charge up here we see is 0. Is 0. Let's look at lithium. And then we'll look at, all right, we're going to look at lithium. Let's go look at lithium. We're going to see that lithium, it's in our group 1, +1 charge. Let's look at another one here. Let's look at nitrogen. If we go out and look at our periodic table, let's find nitrogen. Nitrogen's here, and it's going to form a stable charge of -3. So again, you can just look at your periodic table and read those off. Now, if you get really good, you don't even need to go through and look at the top of the periodic table here. You can learn just by knowing what I've highlighted here in yellow, how many valence electrons, you can back into the stable charge pretty easily, right? We just want to get to how many electrons does it need to gain or lose to get to 8 electrons in the outer shell. Okay. That's the end of our bell work for now, guys. Let's go into our new notes for the day. Let's go into our new notes for the day. So we're going to have a quiz on Friday. I didn't update my slide here. We're going to quiz on Friday about what we're covering this week. Don't forget that. And first, I want to start talking about elements versus compounds as we get into our topic. So we're into your notes handout now, your guided notes handout now. And the difference between elements and compounds. We talked about these at the beginning of the year. Let's just remind ourselves what they are. Right? Elements, these can be found on the periodic table. Examples like chlorine, hydrogen, oxygen. Compounds, though, it's a combination of elements. It could be 2 or more different elements, right? HCl, hydrochloric acid, common compound. H2O, hopefully you guys have heard of H2O, water, before, right? So 2 hydrogens and 1 oxygen. And then at the end there, we have sodium and an OH. We'll learn about that tomorrow. OH is a polyatomic ion. So that's sodium hydroxide. That's right. So compounds, elements are a single element. Find them on the periodic table. Compounds are a combination of elements. And their compounds have new properties, right? H2O, hydrogens and oxygens. Hydrogen's a gas, oxygen's a gas, H2O, that's not a gas, that's a liquid state in our normal temperatures and pressures. So very different chemical properties when they are compounds. So let's talk about ionic bonds. That's what we've been leading up to here as we're talking about what stable charges do atoms want to have. And remember, ionic bond, it's formed by the attraction of oppositely charged ions. Ionic bonds involve ions, right? We know that positive ions and negative ions, opposites, are going to attract each other. So let's take a quick look at our periodic table. And what we want to see here is if they're going to be opposite charges, you look at the left of our table, it's green, right? Group 1, group 2, they're green, except for hydrogen, right? Those are going to be positive charges. Those are metals, right? Group 3, group 4, again, these are where our positive charges are. You see gallium, indium. Okay, we got a bunch of positive charges over here. Whoop. Look where our negative charges show up. Now we're getting into our non-metals. Our yellows here tend to be our non-metals. Our metalloids kind of creep in here a little bit, and at the very bottom here, some metals do. But most of the time, our negative ions here are going to be, the yellow ones here are non-metals. So for most of what we're going to be doing here when we're talking about ionic bonds, it's going to be between a metal and a non-metal. the metal being the positive ion, the nonmetal being the negative ion. They're oppositely charged ions, usually again between a metal and a nonmetal. Let's take a look at how we make an ionic bond. There's three steps. Three steps we're going to follow. So at the bottom of the page here, you see I've got a sodium atom with 11 protons, 11 electrons, and a chlorine atom with 17 protons, 17 electrons. If you notice the sodium, it has 1 electron in its outer shell, group 1. Our chlorine has 7 electrons in the outer shell, it's group 7. The first step into making an ionic bond is that something has to give away electrons and something has to take electrons. And so our sodium is going to give away electrons, so it's going to go away that 1 electron. It's going to fall back. Then its outer shell is its second level there. It's got 8 electrons. It's stable. Chlorine, when it grabs that electron, it's going to fill its outer shell, so it has 8 electrons. Chlorine is going to be stable. Right, so that electron, let's do that once more. That electron is going to go from our sodium. It's going to bounce over to our chlorine. Now, at this point, we've made 2 oppositely charged ions, right? Our sodium lost an electron, lost a negative, so it's now a positively charged ion. Our chlorine picked up an electron, a negative particle. It's now going to be a negatively charged ion, right? Sodium's net positive 1, our chlorine's going to be a negative 1. And finally, our third step. Now we've got our 2 oppositely charged atoms, or ions, and they're going to attract each other. And this kind of attraction we call an ionic bond. So to wrap up today, let's talk about how we're going to write chemical symbols. How we're going to write some chemical symbols. And let's look at our first part here. Remember when we look at the periodic table, when we look at the symbol for an element, that first letter is always capitalized. It's always uppercase. If there's a second letter for our chemical, for our atom, it's going to be lowercase. Right, so here's some examples. Oxygen, just 1 letter, capital O. Chlorine, you're looking at the periodic table, so it's a capital C. That second letter, that L, that's a lowercase L. That's not a capital I. We need to be really, really careful when we're looking at things. Right? Next one, M, capital M and a little G, magnesium. First letter capital, second letter lowercase. PB, tricky one, that's lead. Again, first letter capital, second letter lowercase. And then the last 2 here kind of look similar, right? TI, that one on the right, that's TL. That's a little L. That's not a capital I. You got to be really careful when you write your capital I's so that you know you're not talking about a small L. But if you can remember this part here, guys, that when we're writing element symbols, if the second letter is always lowercase, that'll help you out a lot. So let's talk about how we're going to write that ionic formula. Our first rule, the positive ion always goes first. The positive ion always goes first. This is usually our metal ion. The second rule we got to be careful of, the total charge of our ionic formula must be 0. We have to have the same number of positive charges as we do negative charges. The total charge must be 0. Very important. This is often forgotten and overlooked. This is the number one thing that students make mistakes with. So I want you to really, really be careful. That ionic formula, the total charge must be 0. In other words, we have to have the same number of positive charges as we do negative charges. Okay. Our final rule, if we need more than one type of an atom, if we need more than one type of an atom to balance our charges, then we have to write that number of atoms as a subscript after the symbol. You're familiar with like H2O. Right? We needed 2 hydrogens, so we put that little 2 after the H, and we put it as a subscript right at the bottom. So let's take a look at 3 examples here. Calcium and sulfur, magnesium and chlorine, hydrogen and nitrogen. So the first thing I want you to do here, please, 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 guys, I always want you to do this. Look in your periodic table, figure out the stable charge of the atom. If you look for calcium, we're going to see it's in group 2. We know that group 2 has a stable charge of positive 2. We look at sulfur, we see it's in group 6. Looking at our periodic table, we see group 6 has a stable charge of negative 2. So let's put these 2 guys together. 1 calcium and 1 sulfur. Do we have a total charge of 0? Yes. The calcium gives us 2 positives, the sulfur gives us 2 negatives. Our total charge here is 0. And we would write that compound as capital C little a for calcium and a capital S. Notice we put them together here. They're bound. This is not a calcium atom and a sulfur atom. This is a calcium sulfide. We'll learn that name in a moment. Calcium sulfide molecule. We got to put the letters together for the elements. Let's go look at the next one. Magnesium, group 2. I want you to write that +2 above it. Chlorine, group 7. It's going to have a -1 charge here. So let's look at our charges here. Are we neutral? We got 2 positives, we got 1 negative. That's not balanced. That was nice for the calcium sulfide because they canceled each other out. But here, that's not the case. So we need another negative. How do we get that other negative? We're going to add a second chlorine molecule. Then we'll have 2 negatives to balance our 2 positives from our magnesium. Since we have 2 chlorines, when we write our formula, we're going to put Mg, but we're going to put a Cl2 to indicate that we needed 2 chlorines to make our formula neutral. Hydrogen, group 1, +1 charge. Nitrogen, group 5, it's going to have a -3 charge. Again, we got to balance our charges. We've only got 1 positive. We got 3 negatives. We need some more positives. How many more? We need to have 2 more hydrogens in there. So we need 3 hydrogens in total to have that +3 charge. So when we write our symbol here, it's going to be H3. We need 3 hydrogens to go with that 1 nitrogen. That gives us 3 positives, 3 negatives. Our charge is 0. We're balanced. Let's talk a little bit about naming ionic compounds at this point. A couple rules here. The first rule, the positive ion always goes first. Positive ion always goes first. And we're just going to simply write out the name of that element. Right? Simply write out that name of that positive element, positive ion. The second part we're going to do, we're going to have a negative ion. We're going to look at our negative ion. It's always going to go second, but it's a little bit more complicated, unfortunately. We're going to tweak the end of that name for that element to end in IDE. So our first atom, our positive atom, we're always going to write out its full name, right? Hydrogen, sodium, potassium, magnesium. We're always going to write out the full name for that positive ion. Our negative ion, though, we don't. We have to change it. We're going to tweak it to be IDE. So instead of oxygen, it's oxide. You guys have heard of carbon dioxide. We'll talk about that one next chapter. But you have that IDE ending. So here's some common examples of IDE endings. And you want to be very careful. You're going to need to memorize this. There's not too many, but hopefully they also sound right as you say them. Chloride. That's not chlorine. When we put it into a compound, it becomes chloride. Fluorine becomes fluoride when we put it into a compound. Bromide, nitride, iodide, oxide, sulfide, phosphide, carbide. Right? So we've given you 9 examples here of common negative ions that when we put them together with our positive ions, these are what their IDE forms are. So there's 9 of them here. That may seem like a lot, but hopefully these names sound familiar. Chloride, fluoride, bromide, nitride, iodide, oxide, sulfide, phosphide, and carbide. But that tells us that we are in a bound molecule. So examples, sodium sulfide, one sodium atom and some sulfur atoms, right? That's what we know that they're bound. We said IDE. So on the top of your periodic table here, kind of watch when I come into this window again, we're going to put that little IDE at the top right because our negative ions, we're going to change them so they have an IDE ending. And if you look in there, we look at let's look at period 2, carbide, nitride, oxide, fluoride. So we've got those first 4 yellow ones there. Those are our negative ones. Look at the next row. Phosphorus becomes phosphide, sulfur becomes sulfide, chlorine becomes chloride. Look at the next row. We have selenium. I didn't tell you how that IDE ending is, so we don't worry about that one. Bromide, bromine becomes bromide. Iodine becomes iodide. Right, those are our IDE endings I just had in the previous page. Those 9 IDE endings. Let's go on and talk about worksheet number 1 now. Worksheet number 1 for our naming of binary ionic compounds. Binary meaning 2, 1 atom of each. 1 positive atom, 1 negative atom. Or 1 positive element, 1 negative element. What's the overall charge? Must all compounds have? Hope I cannot stress this enough, guys. That overall charge must be 0. must be 0. If we have to add more of one kind of ion to get there, we add more of that one kind of ion. Question 2, which ion's written first? It's always the positive ion. That's our cation. Remember that T looks kind of like a plus sign like I wrote here. And it's our metals that form the cations. The second one is our negative ion. Those are our anions, negative ions, anions, N there at an. And the anions are non-metals. Which ion has a suffix? Well, we just talked about that. The one that has a suffix is our second one. It's our anion. And we change it to an IDE ending. And there's 9 of them. We have that list here on the previous page. Make sure if they just keep an eye, try to keep those in mind. If they don't sound familiar, work a little bit to memorize the name. It'll be because we will have these on the test. We will have these on quizzes, and I will need you to have the correct IDE form for them. So study those 9. Make sure you know them. The last part here, let's look at a visual representation formula and chemical names. So we're going to do a little bit of an exercise here. This is a good one. If you look at that first example there, what do? We had a calcium ion and a chlorine ion. But notice what I did. I put the positive 2 up here. Right? Put the positive 2 up here next to our calcium, right? Because it's in group 2, and we know that it's going to form a positive 2 ion. Chlorine, put that -1. It's in group 7. It's going to form a -1 ion. I want you to write the charges next to each of these as you start. That'll make everything else so much easier. Take the time. Write down the charges of each of these atoms. Then we get to the visual representation here. The whole goal of our visual representation is, now that we know what our ion charges are, 2 for calcium, positive 2 for calcium, -1 for chlorine, we got to make sure that our net charge is 0. In other words, we have to have the same number of positives as we have negatives. Calcium has 2 positives. Chlorine only has 1. We need another negative charge here to balance it out. So we had to add another chlorine atom. So see our visual representation. I got a second chlorine here. So when it gets to the formula now, it's really easy peasy. Just write down what you see. Calcium? Yep, calcium. How many of them? Just 1. We don't need to write the 1. How many chlorines do we see here? There's 2. So when we put the chlorine in our formula, we have to put 2 at the bottom. Okay. And finally, our chemical name. We name our first atom calcium. We take our second atom, we change it to an IDE ending, calcium chloride. I'm going to skip over the next one. Well, let's do the next one a little bit. +1 for lithium, right? It's in group 1. Oxygen is in group 2. I'm got group 6, so it's going to be -2. What's the charge of a lithium ion? +1 charge. We need 2 of those, though, right? You need to get 2. You need to have 2 positive charges to balance out the -2 from our oxygen. So there's our visual representation there. Note in our visual representation, we have the same number of positives as we do negatives. 2 positives, 2 negatives. Now we can write out our formula just looking at it. We start with our positive ion, our lithium. How many lithiums do we see in our visual representation? 2. How many oxygens? Only 1. So our formula is going to be Li2O. Chemical name, first atom is an Li atom, that's lithium. Second one's oxygen, has to turn into the IDE, right? It's going to be lithium oxide. Okay. Let's bounce down to our one here with aluminum and oxygen. This is the most complicated one I can give you. That's why I want to go through an example here. Aluminum's in group 3, so we see that it's going to have a +3 charge. Oxygen's in group 6, we see it's going to have a -2 charge. These are a little tricky, right? So when we do our visual representation, we're going to put an Al3 plus out there. Awesome, we have our one aluminum ion. But we're also going to need a second aluminum ion, because we're going to have +3 from our aluminum, -2 from our oxygen. Those aren't going to cancel each other out. But if you go through the exercise and figuring it out, what are we going to need? We're going to need 2 aluminums to get to our +6. That means we need 3 oxygens to get to a -6. We're going to find the first place that combination adds up. So we have the same number of positives and negatives. Right? So look at that. 2 times 3 positives gives you 6 positives. 3 times -2 gives you 6 negative charges. So our formula there, it starts with Al. Start with your positive ion. How many of them do you have? 2. End it with your oxygen. How many there? 3. And our name then, name our first ion, aluminum. Look at our second ion. We've got to change it into the IDE, aluminum oxide. Okay. Some quick bit about the back. When we name our chemical compounds, easy peasy, guys. You can just read what you see on the paper. Hydrogen's our first atom, write down that name. Bromine is our second atom, just change it to the IDE, hydrogen bromide. Right? We can continue on doing this. Just write the name of the first atom. Next one would be aluminum. If I go down one, what's the name of the second atom? It's a fluorine, but we got to change it to an IDE. It'd be aluminum fluoride. So going from the symbol to the name, easy peasy. Just write down what you see and change the last one to IDE. This last part here is harder. If we got to go the other way around, it's a little bit harder. And the key thing here I've written at the top of the page, formulas must be neutral. Formulas must be neutral. So how are you going to make sure you do that? Look at your atoms here. Aluminum, group 3, it's going to have a positive 3 charge. Bromide, well, that's the IDE form of bromine. Look that up in the periodic table. You see it's group 7. It's going to have a negative 1 charge. We're not balanced here. We're not neutral. We have 3 positive. We have 1 negative. How are we going to get balanced? We need to have 3 aluminum. Whoop, I got a typo there in my answer. It should be just AlBr3. We have 1 aluminum that gives us our 3 positives. We're going to need 3 bromines to give us our negative. So this formula should be AlBr3. I have a typo there, guys. Sorry. Count up how many we need 3 bromides, 3 bromines to counteract the +3 from our aluminum. Right? Need 3 bromines to counteract that aluminum. All right, and do the same thing with the others. Right? Barium chloride, so what's the charge of a barium? What's the charge of a chlorine, or it becomes a chloride? Make sure you get the right number of each. Make sure you have they balance the same number of positives and negatives, and just write down how many of each atom you needed. All right. Check the answer key for the rest of these, but I want to at least go through this one so you could see some reasoning as you go through it. All right, guys, thanks a lot. Have a good one. Good luck finishing this up. Hope you guys had a good day with your PSAT, and we'll talk to you tomorrow in a live class. Take care. Bye-bye.